is dependent on its translation speed. So the ones which make it for the 97 El Nino, this is the one to make it for the 97 El Nino, when the shallowing was very evident, are the fast-moving ones. Yes. Because if they are slow, they will kill themselves. Sorry.
Okay, probably for the more stronger tropical cyclone El Nino year, my explanation is the tropical cyclone generally location is shift to the east, and the cyclone have more time to move over the ocean and get the more intense.
Right. Yes.
This explanation is nothing to do with the depth of mixed layer.
Okay.
I think there's a difference here. I think he was trying to stress about those that reach category 5. If they are not that strong, then the feedback would not be that strong, and then that kind of impact would not be significant.
Right.
So I think we are talking about different scenario.
Right.
So yes, that's the focus of her talk today.
Yeah. So the further away from ocean, the further away from land, the deeper into the ocean, the faster it moves, the better it is. So this is my point.
Yeah, just a question or clarification. In your talk, I believe you said, can you go back to the slide where you showed all the cases tracking over the warm eddies and the what's back? Yes, that 13 there.
Yeah.
I believe you said that every Cat 5 went over a warm eddy. Is that correct?
Yes. In that region, between 20 to 26 degrees belt. Between this belt.
Okay, what time in the life cycle did it go over that warm eddy?
Okay, we observe from category 1 to its peak.
But is it, can you say, oh, within 24 hours after tricking, for example, after going over the warm eddy, then it reached Cat 5? Or is it sometimes maybe it was 3 days earlier, and one time it was 6 hours early? You know, the timing there.
Yes, okay, you can see from here, this is the best one, all the way from category 1, the green here to black here, all the way over eddy, warm eddy, and this one, from category 1 to 5.
Are each of those dots 6 hours, 12 hours? What are each of the dots?
These are the categories. The green is category 1 and
How much time it takes?
okay, usually it's 2 days, 1 to 2 days.
Okay.
Usually they tend to be very rapidly intensified cases as well.
Like that case C, and I'm not picking
Yes,
on specific
here,
cases,
yes.
but it looks like it's intensifying after it's left the eddy.
Right.
But in case F, it's intensifying over the eddy. So it's that one at the bottom left.
F here. Yeah. So basically, during this critical time, they all encounter eddy because the point is that without this, if it is a flat without the eddy, the ocean will be very cold. The heat counter. How about this one? This is an RI case. This is within 24 hours. It quickly went over eddy and then it did not have, yeah.
So that one
So
actually
it
went to Cat 5 over a cold or a relative
This is a neutral.
minimum. Yeah.
Yes, this is a neutral region, but you went through it at the early stage. But I agree with you, this one, yes. And actually, this is an interesting case. I remember this case. This is called Ma'an, I believe. This was a RI case. It was developed within 24 hours. So actually, another thinking I was having is this: if they are really RI quickly, they just need to go through with the initial kick. They can very quickly evolve, as long as the ocean is not too bad. Because even with, as long as the ocean is not too bad, it can evolve quickly. But one point is this: after it went past this, the intensity could not maintain. Immediately after intensification, category 5, it drops. So, sorry.
There's a certain implication here when you're drawing dots on a scale on that all storms are controlled by the same size as I and local things.
Right.
You have to look at the size of the storm and whether or not it's seeing the whole area around it. You can't look just at the center point.
Yes, exactly. This I totally agree. Because this is starting from 93, and because the JPWC only providing the radius maximum wind data from 201 or 202. So this was the frustration I had also, because there was no size of the, because size matters so much for the ocean cooling. Yes.
Okay. So I think with that, let's thank